Good morning and welcome to our fifth of 6 lectures on the skeletal system unit. This lecture is going to focus on the appendicular skeleton, looking at what are the actual bones that make up the appendicular skeleton, what are our arms, legs, and what are the bone markings that are really important that we'll find on those bones. So just to start, in general, let's make sure we're in agreement on the definition of our appendicular skeleton, because that's really all that we're going to be looking at today. And so the appendicular skeleton is just any bone or any part of the body that is involved with the limbs and allows for movement, right? So this is really our way of interacting with our environment. It includes the joint that actually connects them to the axial skeleton as well. So it might sound weird because you think of your hips and your shoulders as attached and really axial. They might feel axial, but because they're more connective pieces, those are actually appendicular. And everything that connects off of the hip and the shoulders down, all of that is going to be appendicular skeleton. And so we're going to start here by looking at the upper limbs and the shoulder girdle, really focusing on the first point of attachment, and then we'll kind of go joint by joint, looking at what are the bones that make up that joint and how do they slot into each other, what are the bone markings that allow them to fit in perfect to make that jigsaw that we know that the skeletal system is designed for. And so for our upper shoulder girdle, there's going to be only a couple major bones here. It's going to be the clavicle, the scapula, humerus. That's going to look at our shoulder joint. And then we're going to look at the elbow joint, which is going to have our radius, ulna, and how it's connected to the humerus. And then finally, we'll look at the hands and see how those are connected to the radius, ulna. And so we start with how the system is actually connected to our axial skeleton in general. And this is going to be the shoulder joint. And so in the shoulder joint, we have a couple bones. And we're going to start with this one right in the front here, this guy. This is our clavicle. So here's the bone on its own, right? The clavicle's job is to act as a brace for the shoulder girdle. It basically is absorbing any force or shock that hits into the shoulders and allows for us to absorb some of that force. And so a lot of the times people break their collarbones or their clavicles like in football or something, hitting someone, because as you put that force on your shoulder, it compresses the bone, and if that compression is enough, it can end up breaking. Now, this clavicle is actually going to, if we take a look here, the clavicle wraps around and connects to this bone right back here, this kind of like triangle bone, this guy. And this is our scapula. The scapula's job is basically to provide the shoulder blade and allow for points of attachment so that we can facilitate movement at that shoulder girdle. It is definitely an irregular bone, right? We've got some of these like really distinct processes, and it's because the clavicle and the scapula are actually designed to go around and connect to each other, front to back, so that we can make our shoulder joint. And so on our scapula, we have a couple major bone markings that we want to focus on and know. First one is the spine of the scapula. If you look, there's this like raised edge of the scapula. See how it kind of moves up? This raised edge is the spine of the scapula. This is going to be a major attachment site for muscles, right? It's an easy grab, and it's going to allow for a lot of that movement at the shoulder. We also have what is called the suprascapular notch. And that notch, if you take a look at the top of the scapula here, do you see how it kind of dips right in at the top here? That is our suprascapular notch. Notches are really helpful because they allow for some nerves and blood vessels to move not so much through the bone, but have a path to get around the bone and to also innervate the bone in general. We also have the acromion. So if you take a look at how the spine is like raised here, that raised spine leads to this point that like sticks out. It's sticking off entirely of the scapula. And you can see it's the point that attaches to the clavicle. It's, see, clavicle here, and then this piece that raises up. That's called the acromion. And that's going to form the highest point of our shoulder joint, connect to the clavicle, and be really important in actually maintaining the joint of the shoulder, making that socket so that the ball can fit into it. So we then have the acromioclavicular joint. This is actually the connection point between the acromion and the clavicle. So if you've ever heard of someone like separating a shoulder, what they actually did is they pulled the bone of the clavicle away from the acromion. That piece of tissue, that connective tissue, rips apart a little bit. And when that happens, it makes the shoulder less functioning. And all of these things come together to form what we call the glenoid cavity, right? This is a ball and socket joint. And so the socket, the thing that your humerus, right, the arm bones are actually going to fit into is the glenoid cavity. It's just a socket that allows for the head of the humerus. So these all come together to form what we call the glenoid cavity. And this is just really a socket that allows for the head of the humerus to slot in and make that ball and socket movement. And so when we talk about the acromion, clavicle, these pieces are all really important because they come together to form this joint that allows for movement at our shoulder. Right? That then leads us to the humerus, right? Moving down into the bones of the arm. And so the humerus is just our upper arm bone. I've got one right here, right? It's got this circular top. Always remember the top is going to be like the head. It's going to have that ball. And down here, we've got this kind of, if you take a look, we've got this kind of interesting thing happening at the bottom. But our humerus has a couple major bone markings that we want to know because these are really important for the articulation. First is obviously going to be the head, right? The head is the part that actually slots in to the glenoid cavity. It's what actually allows for that connection. The head has a coating of articular cartilage, so that movement is really smooth. But that head is actually the thing that sticks out to allow it to fit into the glenoid cavity. We then have what is called the greater tubercle. So if you see here, there's this like smooth head. And then when we spin it around, you can see that there's these kind of like bumps, right? See this raised piece here? And then there's a little raised piece. So big raised piece, little raised piece. These are our tubercles, right? Small one, big one. And so the greater tubercle is this large one right here. Its job is to act as a attachment point for muscles of the shoulder to make sure movement can happen at the shoulder joint. Right? And so this connection at the shoulder joint is about the head of the humerus slotting perfectly into that glenoid cavity. Muscles of the shoulder will then grab on to the tubercles of the head of the humerus, and that's what allows us to move our shoulder around, right? It's just the muscles pulling up on the top of the humerus. That then leads us down to the distal part of the humerus, right? The lower part of the humerus. And this is where we're going to start to look at the connection for the elbow joint. Now, on our distal section of our humerus, you can see that there's these kind of like notches, these indents, these things that divot in on both the front and the back. So this, if we're looking here, right, this would be my left humerus slotting in. On the front, we have this. On the back, we have this deeper indentation. Now, these are called fossa. So, we have two fossa here. We have on the back, we have the olecranon fossa, right? So, a depression on the back of the humerus. And the job of the olecranon fossa is to allow this part of the ulna that we'll talk about to slot in perfectly. So if you remember my story about my broken arm, it's actually this part of my elbow that I broke. And so when we look here, right, the olecranon fossa is just a divot, an indentation that allows this part of the ulna, the olecranon process, to slot into it. We then have on the front side of our humerus, right, we have our coronoid fossa. So the goal of this guy is, while this one is about, right, if we're holding the bones open, having them slot into each other, the coronoid is about putting this piece of the ulna into that front section of the humerus. So it allows them to come together like this, right? All that these fossa are, right, olecranon on the back, coronoid on the front, are just divots, indentations that allow for the parts of the ulna to actually slot in, right? That's that jigsaw piece that we're talking about. So that is kind of our humerus. Now let's talk about the forearm bones that are slotting into it and kind of talk a little bit more about the radius ulna. And so we're going to start with our radius. Now, if you see in the image and on our guy here, right, the radius is going to be the outer bone when we are in anatomical position, which, if you remember, is like our guy here, right? Hands out. And for this, it's always going to be the bone on the thumb side. So your radius is your thumb side bone, right? So of the two, always remember in anatomical position, right? Our hands are out, and the radius is just going to be the one on the outside in anatomical position on the thumb side, right? And so for our radius, we have a couple pieces that matter. We've got this guy right here. This is the head of the radius. The head of the radius is very circular if you look. That's really important because the head of the radius actually slots into part of the ulna and allows it to rotate on it. We also have the styloid process of the radius, which is just down lower. If you feel your wrist, when you feel what you guys think your wrist is, right, where you'd wear a wristwatch right here, you can feel two bumps on the side. This actually isn't your wrist. I know that sounds really weird, but that's actually the styloid process of your radius and ulna. So basically those styloid processes bump and dip like outward at the bottom. That's why you can feel that like bump on the sides, and then you actually get to the hand bones. So those are the parts on the humerus. Now we're going to talk about the ulna. And the ulna is really, really important here because the ulna is really the bone that slots into the humerus and allows for movement at the elbow joint. And so in general, remember, radius is thumb side, so ulna will be the pinky side, and it's helping to form the joint of the elbow. So in our ulna, we have this like C-shaped section, right? We already talked a little bit about how these and these are slotting into things. But this notch right here is what is called the trochlear notch. This little like track right here is the trochlea. And so the trochlear notch is what allows the ulna to snap on to the humerus, right? So trochlear notch, the C shape of the ulna, slots into the trochlea, this track, this like indented track of the humerus. And in this movement here, right, we've got our coronoid process. This one is the one on the front, and the coronoid process slots into the coronoid fossa, right? Coronoid process of the ulna, this bit right here, fits into the coronoid fossa of the humerus. The way I think about it is when you close your arm, you are putting the coronoid process into the coronoid fossa. Think closed coronoid. When the coronoid process is sitting in the coronoid fossa, your arm is closed. And on the inverse, right, where this is the coronoid, this section right here is the olecranon. This is the section I broke off when I broke my elbow. And when you open your arm up, the olecranon process of the ulna fits into the olecranon fossa of the humerus. Think open, olecranon fitting into olecranon process fitting into the olecranon fossa, closed coronoid process fitting into the coronoid fossa. And that's our elbow joint. That's how that movement is going to work, and how those bones jigsaw to make sure that there is no wiggle room and no overextending, underextending that might risk damage to the muscles or to the bones in general. And that is our elbow joint. Lastly here, we're going to talk about our hand bones, right? So we've got our hand bones here. Really, we're only going to focus on the three sections here, our carpals, metacarpals, phalanges, and really not going to look at any of the specific terminology of these bones because there are so many. And we start with our carpals, right? These guys down here. These are the short bones that make up kind of the wrist slash like part of your palm. And these carpals are going to allow for a lot of the small, precise movement. They're really sliding on each other to make that precise movement happen. We then move up from our carpals down here to our metacarpals, right? These are making up more of the palm, more of the upper part of the palm. And these are going to help, again, connect the fingers down to the wrist, allow that small, precise movement happening at the wrist to kind of be conferred to the long bones of the metacarpals and phalanges. And then that leads us down to our phalanges, right? These guys right here. We have three sections of phalanges on each finger, except our thumb that has 1, 2. And phalanges are just those long bones that extend our hands out and allow our hands to grab, interact with the world around us. So that is our arms, right? Our connection at our arm, shoulder, and wrist joint. Now we're going to jump to the legs and talk about the other part of the appendicular skeleton, which is hips, knees, ankles. So next we're going to jump into the next section here, which is going to focus on the legs and the things that are connected off the pelvic girdle. And so to start this, right, our connection of our legs to the axial skeleton is all going to be focused and centered around our pelvic girdle, right? Pelvic girdle is two irregular bones, right? Two of these coxal bones that when put together will form this kind of butterfly bowl shape that allows us to both slot both of the femurs in, right? And slot them in a place that actually allows for weight to be distributed really, really evenly. And will allow some protection of hollow organs, as well as still having openings through so that babies can still exit through the pelvic girdle. And so we start with these parts of the pelvic girdle. And in our pelvic girdle, we start with our ilium. Now, the ilium is actually the part of the pelvic girdle that is like the flat part, right? So think about the ilium as the flat upper section of your hips. We usually call this the false pelvis because while yes, it is your hips, it's kind of the flare out of the hips. And really the more important stuff of weight support is happening lower down in the bowl. And so the ilium is just the upper bones, the like flatter part of the hip bones. Now at the ridge of this ilium, at the ridge of this flat section, we have what is called the iliac crest. The iliac crest is just the top section of the pelvic bones. When you feel your hips and you're feeling that like top section, that is the iliac crest. So really the piece that you're feeling oftentimes of your hips is the iliac crest, just the ridge of that ilium. That then takes us down into the ischium. And the ischium is this lower pelvic bowl. So just the inner part of the pelvis that you actually have that like circle for. That's where most of the weight is actually going to be localized, where more of the support's going to come from, especially when sitting, right? So when you sit down, it's that ischium that's supporting virtually all of your weight there. And that's the inner pelvis. The true pelvis is kind of how we classify that. And so if we look here, right, this will be the ilium, but then down here, this section right here, that will be the ischium, because that will actually be the part that's going to support weight. We then have this. Do you see how there's like this gap, this divot right here? That is the greater sciatic notch, and this is what will allow for your sciatic nerve to run down and through, down to your legs. And sometimes it can actually get kind of like stuck / it'll rub against that, the bone, that greater sciatic notch. And that's why we can have some like pain or flaring down our leg, is because as the nerves run on that bone, it can kind of overwhelm them and cause like senses of numbness or shock. Right? Then we have the pubic bones. Those are the like lowest part down here. Those are these intersection, closest towards the front of the pelvic girdle. And those will connect the two coxal bones together at the pubic symphysis. So this is a little bit of cartilage right in the middle of where the two bones connect to each other. We need this cartilage because we need some level of movement to actually facilitate childbirth, right? So when a baby is being born, as it comes out, right, its head has to be able to mold, shape, and come through the pelvic girdle. Because of that, having a little bit of cartilage here is really important, because that cartilage will allow for some level of expansion to make that process a little bit easier. And so that's the pelvic girdle, right? That is most of the important bits. But now let's talk about how that pelvic girdle is going to actually facilitate and connect the legs into this girdle to make movement with our legs actually work. And so we kind of have to jump into our femur. Now, for our femur, it's really important to understand how this connection works. And so in your hip bones, in the coxal bones, you'll see that there's this like circle, this socket. You have one on both sides, right? And that socket will be right here. That is called the acetabulum. And the femur slots in to that acetabulum. And so the femur is just our longest bone in the body. It is the strongest bone in the body. And it's going to support a ton of weight because it is connecting directly into that pelvic girdle. And so the head of our femur, right, this smooth part, is what's going to fit into that acetabulum, right? Ball into socket, allowing for our movement. So it's really important that we understand that that head fits into that acetabulum. That's how we actually connect at the hip joint. We also have on the opposite side of the head of the femur, we have our greater trochanter, this massive ridge right here, right? That is where most of your hip muscles are going to attach, and some of your leg muscles as well, right? Your thigh muscles, and that's going to allow for a lot of movement. It makes a really good place to grab on, and so it's going to facilitate a ton of movement. We also have the lesser trochanter. So if this is the greater, this guy right here is the lesser. Also going to be a muscle attachment site. Remember, those trochanters, tubercles, they all tend to be muscle attachment sites, right? And so our hip fitting into our acetabulum, that's really the big piece we want to know for how that connection works. We then go down to our lower section of our femur, right, the distal part of the femur. And if you look right here, right, this is what is called the patellar surface. And so we'll look at it on a real bone, right? So you have the patella, this kneecap bone, and where that patella sits is going to be right on the patellar surface, right? And so that is just the surface, the like kind of smoother part on the front of the femur where the kneecap is going to end up sitting and glide over to make sure that movement at the knee is protected and as stable supported as possible. The patella is the bone that actually sits on that joint, right? Protects that joint and acts as kind of a leverage piece so that as the muscle moves with that patella, it'll kind of like slide the patella. That's why your kneecap can kind of move and shift. That's actually by design. And so the patella is really important to not only protect, but also add to the leverage that the muscles can use to to make more movement and facilitate easier, better movement. That then takes us down to our tibia and fibula. So femur is this guy right here. And now we've got to talk about how it connects to the large bone, right? This is the tibia, the large bone of the foot. It's also the inner bone of the foot. So if we look at our guy here, right? Tibia will be the inner bone. And so takes a ton of weight, right? This is like also the shin bone you usually think about when you bump your shin into like a table or something. You're actually bumping the tibia. And there's very little muscle on the front of the tibia, which is why it hurts really bad when you hit it. It's because you're almost hitting directly into the bone. On the tibia, we have a couple really important bits that we want to know. First and foremost is going to be what is called the tibial tuberosity. So, do you guys see this right here? Right, that is our tibial tuberosity. It's a muscle attachment site, right? Any of our rules of T, the tubercles, tuberosities, trochanters, they all tend to be ligament/muscle attachment sites. It's just to enhance the stability of the knee joint to make sure that it's as stable as possible to the femur above. We also have what are called malleuses. So this is as we go down. We're now going to talk about the distal part where we're now going to form the ankle joint. And if you see here, right, we've got this kind of like bump out. And when we're looking at both of them, you can see that there's one bump out here and one bump out here, right? The tibia has a bump on the side and the fibula has a bump on the side. The medial malleus is on the tibia though. And that, when you feel your ankle, you feel those two like bumps, those two balls, in the same way that I told you like the wrist, this is actually not your wrist, right? You're feeling the ends of those two long bones. The malleuses are the same way. When you feel your ankle, when you feel the inner part of your ankle, that inner ball, that's actually just the medial malleus. It's the end part of the tibia, okay? And so femur, right, slots down to our tibia here. Tibia then runs down, and this is our medial malleus. That's going to be where the ankle is, and then the foot will slot into that. Okay? So that's our tibia. We then have the fibula. That's going to be the bone that sits right next to the tibia, right? So tibia, big one, fibula, the little one. Think if you tell a little lie, we call it a fib, and so fibula, smaller bone. Head of the fibula, right? Pretty easy job that it's doing. It's just helping to form the joint here between the tibia and fibula, right? So just forms part of that articulation. And we have the lateral malleus. So when you feel the outer bit of your ankle, you're actually feeling the lower part, the lateral malleus of the fibula. Lastly, we're going to talk about the last joint that we kind of care about, the last connection here, which is the connection of the tibia and fibula to the actual ankle. And so for this, we're going to talk about two specific tarsal bones, the tarsals in general, and then we're going to talk about the other bones of the foot. So we start with this general classification, which is that all of the bones, right, all of these bones here, so everything in blue on that image, are all tarsal bones, right? So carpals here, you drive your car with the carpals, and your tarsals lead to your toes, right? So the tarsals lead to the toes. And so all these bones here are our tarsals. There's a lot of them that are short bones. Some of them are actually irregular bones, but all of them in general are working to facilitate movement and change the balance and weight distribution of the foot to make sure that we are as balanced as possible. So one of the major bones that we care about here is this top bone of the foot, the one that actually slotted into the tibia, right? That is our talus. So think top of the tarsals is our talus. And it's going to be what actually connects the leg to the foot to facilitate this movement at the ankle. We then have, so talus is this top bone, calcaneus is this bottom bone of the foot. So your heel, the heel bone of your foot, is the calcaneus. Really important for standing, supporting weight, right? It's a really, really strong bone. And it's going to be where your Achilles tendon connects. So it's also going to help to facilitate some movement and anchor down some bone or muscles. We then move on to the red section, our metatarsals, right? These are going to be long bones, and they are leading out to our toes. But they are going to make up most of our actual foot. So when you think about your foot, it's actually mostly metatarsals, like on that end section. Again, big job of the metatarsals, just distribute weight, allow for movement, and then lead down to the phalanges, these last guys here, right? Similar to how the fingers had three of the phalange bones for each one, except the thumb. This is the same way. Each toe has 3 phalange bones, except the big toe, which has 2. So that is it for our standard 5 information, right? That's it for bone markings, appendicular skeleton. Note sheets, again, are down in the description. Any questions, feel free to leave on the video, leave on Classroom, and I am happy to help answer those. And I'll see you all in the next video.